All right, good morning, everybody. Continuing with solving today, we're going to go ahead and take a look at example 3, which says find all solutions. We're going to add exact to that. Find all exact solutions in radians. Now, we have added an exact because we want to find the exact solutions using the unit circle, but this one's a little bit different because unlike example 1 and example 2, where we are given intervals to find the solutions, when it just says, hey, find all solutions in radians, that means we want the coterminal solutions as well. So once we find out what our x is equal to, we are going to have to find all coterminal solutions with that value as well. So let's just go ahead and take a look at the setup of this problem. We've got 2 times cosine times sine equals 0. Now, the problem with this one is that there are 2 different trig functions or 2 different kind of variables like we had in the last problem, but can we take out a GCF? No. But do we need to take out a GCF? This one's kind of weird and a little bit counterintuitive because it's actually already factored. All of these items are already joined by multiplication, so I don't need to take out a GCF. I don't need to do any manipulation to it. This is already in factored form. If I have 2 times something times another something equals 0, that means one of those somethings has to be equal to 0. So either cosine x equals 0 or sine x equals 0. So going to our unit circle, cosine refers to the x value. So what angle or angles have an x value of 0? This one right here. And this one right here. Now, we are in radians, so I have 2 solutions that give me a cosine of 0. So I'm going to write that in terms of radians. X equals pi over 2, and x equals 3 pi over 2. So that accounts for the angle that has a cosine of 0, but because we are also looking for any coterminal angles as part of our solution, we first have to define k to be equal to all the integers from -2, -1, 0, 1, 2, all the way to infinity and negative infinity. And then to each of these solutions, we are going to add 2 pi k. This shows that these angles within 1 rotation of the unit circle are solutions, but adding 1 rotation, 2 rotations, 3 rotations as we plug in different values for k, and as we look at those negative angles, that all of those would have the same solutions. So these are 2 of my solutions for this equation. So when you aren't given an interval and it says find all the solutions, that means find the coterminal ones as well. So we have to define what k is, and we have to add either 2 pi k or 360k to each of our individual answers. So let's go ahead and not forget about this second part of the equation that says sine of x equals 0. So now we are looking for where the y values of the angle are 0, which would be at 0 and pi. So x is equal to 0, x is equal to pi, and then because we want the coterminal solutions as well, we add 2 pi k to each of those, giving me a grand total of 4 solutions. And the calc teachers have said that it's very important that you define what k is, either on every single problem, or a lot of times I just say, hey, at least do it somewhere on your page. So you have to tell me what that k value is, because how do I know that k is an imaginary or something irrational? So you do have to specify that k is the group of integers. So we have now done 3 solving problems, and as you can see, every problem kind of has its own little weird nuances, and it's kind of figuring out what you would do as either an Algebra 1 problem or an Algebra 2 problem that can make these a little bit challenging. So kind of sifting through the trig and figuring out just basic mathematic-wise what you would need to do to solve. So big picture idea, if there's no quadratic terms, you want to try to combine like terms, like an Algebra 1 equation. If there is a quadratic term, you are going to need to try to factor it. Also, if you have two different variables, you will need to try to factor it. And variables meaning trig functions here. If you have two different variables and it's already factored, you can go straight to using that zero product property. So let's go ahead and turn the page. And we are now ready to look at example 4. So on this one, I want you to add in that word exact again. So exact means we're going to be using our unit circle. I'm going to go ahead and zoom in a little bit here. All right, so exact means we are looking for the solutions on the unit circle, and finding all the solutions means we are going to be looking for the coterminal ones as well. So from the very beginning, I'm going to start by defining that k value. That k is equal to z, or the set of the integers. I would put some stars around this so you remember to do it. So looking at this problem, we've got 2 cosine squared of x plus cosine x equals 0. So the first thing that should jump out at you about this one is that we have a quadratic trig term, so that we should try to factor this. So we're going to write kind of our thought process to the left. We've got a quadratic, which means we're probably going to have to factor it. But before we factor it, what does our equation need to be equal to in order to factor? It has to be equal to 0 in order to use the zero product property. So is it equal to 0? Yes, sure is. So now we can factor this. Now, how are we going to factor this? Folks, what's the very first thing we check for when we are factoring? Always a GCF. So as I'm looking at this problem, what is the biggest item I can take out of 2 cosine squared x plus cosine x? And remember, folks, if it helps, think about what you would do if this was 2x squared plus x. Well, we could take an x out of both of those, which means we can take a cosine x out of both of these. So cosine x, that leaves me with 2 cosine plus 1 equals 0. So now it's factored, it's equal to 0, so we can use the zero prod prop. So either cosine x equals 0 or 2 cosine x plus 1 equals 0. So folks, if you want, go ahead and pause the video and see if you can solve those 2 mini equations for x, not forgetting that you will need to include the coterminal solutions as well. So if we are looking for cosine, we are looking for x values of the angle that equals 0. So if I look at my unit circle, and this is why I didn't want to zoom in too much, I have an x value equals 0 here at 90 degrees and here at 270 degrees. So those are going to be 2 of my solutions. So x equals 90 degrees and x equals 270 degrees. Now, because we want to find all the solutions, we are going to have to find the coterminal ones as well. Now, in the last problem, we added 2 pi k, but because our units is degrees here, we are going to be adding 360k. And that's actually kind of a common mistake on the test over this, well, on the written test over this, is students would sometimes have their answer in degrees and then still add the radian coterminal unit of 2 pi k. So make sure that these are consistent with each other. So those are 2 of my solutions. And just to show you with the calculator that the coterminal solutions really do work, what I have done is I took the cosine of 90 degrees, which is 0. Then I took 90 plus 360, which has a k value of 1. That also gives me 0. Then I took cosine of 90 plus 360 times 2, so plugging in 2 for k, then plugging in 3 for k. Then I did minus 360, so that would be 360 times a negative 1. So this shows you that all of these angles, as I rotate 360 more, 360 more, or going negative, 360 less, 360 less, 360 less, all of those different angles have a cosine of 0. So when it finds all solutions, there actually are an infinite amount, which is why we define that k value as all of the integers and how we specify it by hand. So moving on to the right side of this one, we've got 2 cosine x plus 1 equals 0, so subtract 1. So 2 cosine x equals negative 1, divided by 2. So where does cosine x equal negative 1/2? So going to our unit circle, I had a smaller unit circle. There we go, we'll use this one. So where is cosine equal to a negative 1/2? So first, cosine is an x value. So quadrant-wise, where are x values negative? In quadrant 2 and quadrant 3. So I'm going to be looking here for a negative x, which would be here at 120 degrees, and then a negative 1/2 here, directly below it, at 240 degrees. So those would be my other two solutions. So x equals 120 degrees, x equals 240 degrees, and we're going to add 360k to both of those. All right, so moving on to the next problem, and again, we're doing a lot of these and you're going to have quite a bit of homework over these just because I really feel like you need to practice with a bunch of different scenarios because every problem is a little bit different. So moving on to example 5, it says find all exact solutions for this interval. So because we are given an interval, there will be no plus 360k with this. With our solutions. Because this is saying, hey, I don't want any further rotations like 720 degrees. We only want angles that are within one rotation of the unit circle or regular quadrant 1, 2, 3, and 4. So looking at example 5, we've got 2 cosine squared x minus 5 cosine x equals negative 2. The first thing that should jump out to us is that cosine squared. So we've got ourselves a quadratic, which pushes us to say we are probably going to have to factor this, but before we factor, it needs to be equal to 0. Is this one equal to 0? Nope, not currently. So since it's not equal to 0, the first thing we're going to do is slide that negative 2 over to the left side, which gives me 2 cosine squared x minus 5 cosine x plus 2 equals 0. Hooray. And now we can factor this. Now, folks, I'm going to go ahead and sidebar to the right here to factor this one. Because we did practice a little bit of normal factoring kind of earlier in the chapter, but because this has an a value in front of the quadratic term, we are going to have to use either the x method or guessing and checking here. So if you've forgotten how the x method works, I'm going to go ahead and show you. We've got 2 cosine squared x minus 5 cosine x plus 2. So how the x method works is we start with a product of the first term, a product of the last term, and we're trying to get to a sum of the middle term. So what product will give me 2 cosine squared x? Well, let's start with the 2. 1 and 2 will give me a product of 2. what will give me a product of cosine squared, cosine, and cosine. How will I get a product of 2? I'm going to do 2 and 1. You'll see why in a moment. And then we multiply on the x. So 1x times 1 is, 1 cosine x times 1 is 1 cosine x. And then 2 cosine x times 2 is 4 cosine x. So if I need this to give me a sum of negative 5 cosine, we're going to have to adjust both of these signs and thus adjust both of those signs to be negative, making sure that when we adjust those signs, they are giving me the correct product. Negative 2 times negative 1 is indeed a positive 2. So then to write my factors, remember we go straight across, because when you have factors, you don't actually FOIL the terms that are in parentheses together. So this turns into cosine x minus 2 and 2 cosine x minus 1 equals 0. So now, using the zero prod prop, we are ready to set this guy equal to 0 and this guy equal to 0. So we get cosine x equals 2. Now, if we look at the unit circle, if we're looking for a cosine or an x value of 2, it's like, yeah, that's not going to happen because the smallest x value I can possibly have is negative 1, and the largest x value I'm going to have is 1. Also, if you think back to your trig days and the trig graphs, those graphs oscillate between negative 1 and positive 1 for those range values, so you know that it can never be greater than that. So cosine x equals 2, it just straight up is not possible. So to find this x value, it is not possible because cosine x is always between negative 1 and positive 1. Now, another way you could have figured this out, that this was not possible, is you could have tried to use your calculator to solve for x. To isolate this x, we would do inverse cosine of both sides. So if I do inverse cosine, so second cosine, of 2, your calculator gives you a domain error. So this is not possible. So it's not that it's extraneous or it gives me something undefined. It just kind of isn't solvable or isn't possible. And it's not even that we get something imaginary. It just can't be solved. So moving on to the right part of our expression. I'll try to zoom back in without making the camera go too crazy. All right. Here we go. So now, looking for any other possible solutions, 2 cosine x minus 1 equals 0, so 2 cosine x equals 1. Cosine x equals 1/2. So cosine is x values. So what quadrants is x a positive 1/2? Well, we have positive x values in quadrant 1 and quadrant 4. So a positive 1/2 at 60 degrees and a positive 1/2 at 300 degrees. So x equals 60 degrees and x equals 300 degrees. Do we need a plus 360K for this one? The answer is no, because we only want the angles that are on this interval. So if I add 360 to this, that would give me 420, and that's beyond one rotation of the unit circle. So those are my only two answers, and we don't need to add anything else to that one. All right, folks, we're going to go ahead and stop this video here because in the next problem, we start getting into double angles and how we counteract those when we are solving.